Good. So the goal of my talk is to provide some clarity in what I think is a really confusing space. And I'm going to start with a story. So I am a failed physicist. As an undergrad, I tried to do physics. Very literally, I'm not smart enough to do the more abstract math, so I moved to computation. And my first job out of undergrad was working as a computational physicist for the National Lab. So I solved physics problems that really smart people created, but I did it with computers and computation. And I worked in the weapons program, actually. And I was there, this is about 2000, and then in 2001, 9/11 hit, and very much the focus of the government shifted from kind of more traditional operations to intelligence. And they needed those that knew about computers and had clearances to move into the intelligence community. So I was quickly ushered into the intelligence community where I stayed for 3 to 4 years. And in that time, I worked with some of the most secure and sensitive networks, I think, on the planet. I mean, these are very literally networks that if someone broke into, people would die. And it was at that time when I realized that there was a huge, if you look at infrastructure, there's a huge mismatch between computers and networks. So intelligence agencies assume that the threat has the resources of a nation state, of course, right? This is buying people off, this is driving big trucks into buildings, whatever it is, right? And the general customer doesn't have this type of this type of a threat environment. And so market forces aren't going to create technologies that are going to protect against this. That's fine. For the intelligence community, if I have a computer, I can program it in a way that will withstand these types of attacks. And we had many developers that would do that. Networking was very, very different. So networking, you would buy some networking gear, you could configure it, but like what you bought and what was petrified in silicon at the vendor was not necessarily programmable in the classic sense. And so while we could bring to bear standard computer science in the realm of compute, in networking, it was very difficult for us to get the guarantees that we wanted. And that was actually the beginning of the idea that became SDN when I was at Stanford. And this picture is the system that OpenFlow was invented on. This is me right before I got my PhD in Stanford, in one of the offices, that then became SDN and OpenFlow and everything else came out of that. So unfortunately, since then, there was this original technical work that happened. There's been an awful lot of confusion in the industry. And if you asked me what SDN means today, I actually don't really know, because I think that it's been kind of chewed through a ton of marketing departments, and what was initially a technical contribution is lost. What I'm going to try and do is just define very clearly what SDN is, and then how it's being used as far as customer value. Okay, so what is SDN? SDN is this technical concept that came out of work. It was actually coined by a reporter from MIT Tech Review named Kate Green. So she said, oh, this work that you're doing at Stanford is great. We want to give you an award. What do you call the work? And we're like, eh. She's like, well, I just did an article on software-defined radio. Let's call it software-defined networking. This is in 2009. OK, fine. So that's where the term, and the term was based on this technical work that was meant to build systems. So at the time, what was the promise of SDN? It said, listen, if I have a government or anybody that builds gear, and I've got requirements that you don't know about as a vendor, I can implement them myself, and I can do it in software without waiting 4 years and $10 million as an ASIC design cycle. I mean, it's something I could do in software quickly. And something I didn't talk as much about, we actually proved that with this type of architecture, there are guarantees you can have that you can't have with traditional networking. It doesn't matter why, it's just something that we proved. The most important thing from this long kind of litany that I've just given you is that it was never for customers in the classic sense. It was for people that build systems, right? It's like Python programming language, right? Like some people use Python and they're system implementers, and some people use it to make products, and then other people buy those products, like a game. But SDN was a mechanism, right? It was a mechanism for people to build things, And so it's very interesting to ask, okay, so what can you build on top of this? And not confuse this mechanism with the final product. So one of the, I think, key or killer applications for SDN is network virtualization. Now, network virtualization isn't SDN. It's something that you could build with SDN. And in fact, the original team that did a lot of the work on OpenFlow and on SDN went on to build a network virtualization system. So I want to talk about what that. But first, I just want to define what network virtualization is. So forget everything that I said about SDN. Let me talk about network virtualization really quickly, and then I will bring the two together. OK, network virtualization is like server virtualization. So what is server virtualization? Server virtualization, you change the concept of a server from atoms, from physical hardware, from sheet metal and chips and stuff. You change the concept to software. And once you've done that, you have all of the operations of software. I can clone, I can expand, I can dynamically provision, I can move it, I can snapshot it, I can rewind it in time. I mean, software is awesome because you programmatically control it. You kind of control the laws of physics. So network virtualization is the same thing. So given some networking hardware, you have some virtualization layer, and on top of it, you create a virtual view of a network. And that looks like a physical network. It acts like a physical network, but it has the operations model of software. You can create it dynamically, you can grow it, you can shrink it, you can move it around, you can clone it, etc. So that's network virtualization. Network virtualization is just like server virtualization, but it's in the networking paradigm. And later in the talk, I'll talk about how this is being adopted and why people are using it and why it's important, yada, yada, yada. So I want to talk about two of my favorite trends in all of networking and how they align to SDN and how they align to network virtualization. So the first one is, in the early days of Nicira, we worked with kind of the lunatic fringe, right? I mean, we're a very small startup. We were coming out of Stanford, and so we'd work with those that are real innovators. And we worked with many of the mega data centers and kind of the household names that you know, but that are very aggressive on the technical sense. Whether it's Google or Amazon or Yahoo or Facebook or eBay or whoever. And never mind what we did. If you walked into those data centers today, something very interesting has happened kind of while we were all sleeping. And that is functionality has already started to move from networking hardware into software on the edge. So if you look at one of these large data centers, which run, I would say, the majority of the world's workloads, or at least some large percent of the world's workloads, you already have these very, very simple network hardware. And you have these applications at the edge which implement the functionality we've normally seen in hardware. Right? The software will implement billing. It'll implement security. It'll implement mobility, a lot of visibility and debugging. And the reason for this is very simple. If you do this, you control your features, and you decouple those from hardware. So now you have two totally different purchasing decisions when it comes to, hardware now is providing the function of, I'm going to move packets very quickly at a good price performance, and functionality is now implemented in software. Now, this has nothing to do with the SDN that we did originally, but it makes a lot of sense for those that control their applications and rewrite their applications. If I'm writing Gmail and I'm Google, I'm going to implement as much as I can in software because I've got all of these developers and they're awesome. And applying awesome developers to awesome problems lead to awesome results. And so the more that I can control, the better. So if you ask me, this is the model for how we should think about data centers, where you have hardware providing basic hardware services, and you have software providing functionality. But the problem is the only companies that can pull this off really are the Googles of the world. You need to have very skilled developers. You need to have the control of the application. This isn't going to work for your Exchange server, right? You have to rewrite the application in order to do this. But this is the model. If you want a model, what is the cost model and operational model of the data center of the future? This is it. Very simple physical hardware that passes packets and functionality and software, right? Everything is automated, totally decoupled, and the feature velocity of the software is great. So that's the first trend. The second trend, so this is actually my favorite trend in all of networking. So with the rise of server virtualization has come the rise of virtual ports, because every VM needs to connect to a network. And so for every VM, there's a virtual port. And as of last year, the number of virtual ports, those are ports that are connected to virtual machines, exceeded the number of physical ports globally. Like the implications of this are like actually staggering, meaning VMware in some senses by port count is already one of the largest networking companies in the world. There are so many of these ports that are attached to VMs, and not only that, those ports, which are in software on the edge, are managed by software switches on the edge. And if you have a single server today, it's not unlikely to have consolidation ratios of 20 or 40 VMs per server, right? I mean, I've got customers that have 200. And for those, to have 200 machines, which is more machines than I had on my entire floor at Stanford, on a single server, you need to have a lot of networking to connect those machines. So the second trend is, kind of again, while we were all sleeping, the networking edge, all of this functionality has moved from the physical network into the hypervisor, the servers. And it's on x86. And it's already doing a lot of networking, and it's already touching all of the packets. I mean, if you use VMware today, or KVM, or anything else, you're already doing a lot of networking in software. Real networking. I mean, this is not like some new form of networking. I mean, this is L2, this is L3, this is span, this is counters, this is ACLs. It's being done in software today already for the majority of the world's workloads. So what network virtualization says, it says you've got these two trends. You've got data centers that those that can do it are building in a way that functionality is in hardware. And you've got applications which are moving to virtualization, where you've got functionality in the vSwitch. And so what network virtualization says is, if we can use SDN as an approach, as a tool, to build a layer, that layer should be able to run on any type of networking hardware and take advantage of it if it's differentiated. The networking hardware is very important here, right? Some networking hardware is definitely better than other networking hardware. And on top of that, you can run anything. You can run your enterprise apps, you can run your new apps. But ultimately, you get the same cost model, same operational model, same innovation model that the big guys that are building their own data centers have. And again, I want to draw this back to server virtualization. If you control your own application, virtualization makes a lot less sense, right? You do your own clustering, you do your own HA, you do your own data replication, right? But if you don't control that, or the app's already written, virtualization provides a layer that you get all of the operational benefits of software without having to rewrite that. Network virtualization is identical. So very quickly, how these things are generally implemented. And by the way, I'm not talking just about what VMware does. It looks like this is what the industry is doing more broadly, right? So whether it's Microsoft or Cisco or Red Hat, I mean, this is the approach. I'm actually trying to give you a general sense of how networking is changing, because I've been in networking a long time. This is the most drastic change I've ever seen. So if you look at a server has a VM, and companies like VMware have decoupled the operating system from the server by adding a hypervisor, right? But they haven't decoupled it from the network. If you still look at the address, it's physical. If you look at the default gateway, it's physical. It's talking to physical services. That's why you can't take VMs and move them anywhere without breaking network services. So the idea of network virtualization is you already have a hypervisor, and it's already decoupled the operating system from the server. Let's add a software layer and then expose virtual networks that will support L4 through L2 through L7, all network services the applications need. And so now, say I'm building my cloud, or I've got my IT shop or my data center. I create a VM. I create 10 VMs. I create a virtual network. Let's say I want it to be an L3 network and have load balancing and whatever security properties. I connect the VM to the network, and now the entire application has the operational model of virtualization. Dynamic creation and growing and shrinking and moving and all of that. Where today, and this study's been done to death, and I'm glad it has, if you look at most clouds, the #1 bottleneck to spinning up a full application, not just an OS, a full application, is doing all of the network cruft. It's a baroque, eclectic, old system that we need to evolve. Okay, so this is supposed to be a very confusing slide, so listen to me and don't worry about the slide. You're not supposed to understand it. Applications in the real world are confusing, right? I mean, they've got a lot of causal links and graphs and a lot of requirements. And if we have this view of the world that everything is a VM, it's inaccurate. This is actually a real-world example from a customer of just one application. It was a Microsoft Exchange. So if you wanted this application to have the provisioning dynamics of a VM, you'd have to virtualize all this other stuff. So I just want to walk through kind of like what's kind of the old way of doing networking versus this. So the old way is, OK, so if I have an application and it's got requirements from the network, I go buy boxes or configure boxes, or I take atoms like wires and I wire things in a certain way in order to represent that. So in this case, I need a DMZ, I need multiple tiers, I need boxes that enforce security policies, and all of these are represented in boxes that I've wired and managed box by box. And on top of that, you implement your application. So a couple of things to note. That took a long time, and it was expensive, because I had to go buy things and I had to wire them up. And that physical instantiation of that network is really only good for that application. Now, you can build networks that will be good for multiple applications, but you're limited on the type of applications you can run on them. And in, say, a hosting data center where you want to run big data that wants 10,000 node L3 router and you want to run a bunch of enterprise apps, this normally creates multiple physical silos. So what network virtualization says is, it's all software. So build your physical network however you want. And I think I've seen it all. I've seen a lot of great Cisco-validated designs, a lot of very simple L3 ECMP networks. In fact, the majority of large data centers are very simple L3 ECMP networks. I've seen InfiniBand. I've seen Trill. Build your physical network however you like, using best of breed or your preferred hardware partner. And then in software at the edge, the networking is implemented. And then for deploying something like this application, the multiple tiers, the firewalls is done in software. And the same hardware configuration will host some arbitrary numbers of these. And it's done programmatically, without changing or touching or wiring or whatever. That's the idea. And again, even though I'm up here as a VMware guy, I really think that this is the movement that we're seeing for all of these guys you hear in this space are kind of achieving towards. I think this is where we want to go as a community. I mean, you've removed the largest operational hurdle in getting a cloud, if you'll permit me to use the term cloud, by virtualizing it away. So another thing that isn't super known is there's actually a lot of adoption. So my office is often a rickety United airplane somewhere in the sky. I do probably 80% travel, mostly with customers and partners. And I've done this over the last 4 or 5 years now. And this stuff has kind of moved beyond the realm of science fiction, and you're actually seeing a lot of adoption. And I personally really like to talk about kind of use cases and customers and traction and so forth. And so I'm going to talk both the positive and the negative. Because again, I think to be a little bit intellectually honest, it's good to show what works, what's hard, what doesn't work. So for the rest of this slide, I'm just going to focus on how this is being used, why it's being used, why it's being adopted, and then how organizations are having a difficult time consuming it. OK? So let me talk about NTT Communications. So NTT Communications, we just did a public announcement of them recently. I mean, this is enormous. This is what, second largest telco, I believe, in the world. And when we first started working with NTT, it was actually right after the tsunami. And you had the Fukushima Daiichi nuclear power plant disaster. And so Tokyo in particular is like one big data center, as far as I can tell. Everything is hosted and everything is virtualized. And the problem is because of power shortages and power outages, they were doing rolling brownouts. Meaning throughout the city, they're like, okay, we're going to brown this out, we're going to brown this out, and we're going to brown this out. And as a result, of course, anything that was in that area would have to be powered down. And so there is a lot of hosting that goes on. And listen, if I'm hosting as a desktop as a service, and like that data center gets powered down, like my users are sunk. And so what we worked with NTT was actually another group called NTT SIC. They had a desktop as a service. And so what they wanted to do is they're like, listen, we want to take our desktop as a service. So you got some guy in some office in Tokyo that's kind of doing his word processing, but that VM is being hosted in a data center somewhere. And so what we want to do is if they're going to brown out that data center, we know that, why don't we just go ahead and move it to another data center and not disrupt anything? So traditionally, from like a networking standpoint, this is actually very difficult. Actually, I don't think you can do it unless you probably replace a whole bunch of gear and you have a whole bunch of planning, you have people on on the ready to start typing commands. So we actually virtualized the network, and then we did this. We did this so that like, as they would brown out areas, we could move full workloads, desktop as a service, ahead of them to these different data centers. So another one is rack space. It turns out that it's actually very hard to host enterprise applications in the cloud because of the network. If like you take up, like if you're an enterprise and you've got all of this kind of old eclectic technology that's been around for quite a while, to try and pick that up and to move it into a cloud, there's going to be a mismatch between the requirements of those workloads and the networking services provided by the cloud. This is why most things that go to the cloud are new things, not to be overly generic. But like it's new development, it's web services, things that are kind of made for these types of environments. But like if you're going to like try and run, whatever, Microsoft NLB or TIBCO or a lot of these other that have more sophisticated network requirements, that clouds weren't built for that. So we've been working with Rackspace for a very long time, and these are very large deployments so that you can run pretty much any type of workload in a cloud environment. And we're talking, many tens of thousands of different types of workloads with all sorts of different configurations in the same type of physical infrastructure without VLAN silos or any of that. And the final one is kind of one of my favorites. So eBay is a sophisticated company as far as I can tell. I mean, they've got great innovation, great developers. It's the market leader in their market segment. And they built actually a very sophisticated developer cloud. But the problem is like, while you can spin up a VM on the order of whatever, say 30 seconds or 20 seconds, the actual network provisioning, you'd spin up your VMs, and this is a developer cloud. So a developer sits down. They had a great idea driving into work. They sit down, they spin up 3 VMs, but then actually to get the networking resources for that was between 7 days and 49 days. Right? A trouble ticket went out, and then someone was sick or hungover or whatever, and it just takes time, right? And so you have this, listen, like companies live or die by innovation today. Like if you're building mobile apps and you're like, you're like 2 days behind on your idea for Candy Crush, like this is like a difference in revenue of a factor of 10, honestly. Factor of 10, right? And so like waiting 7 days is death in like this new realm of like we need to get stuff done now. And so we worked with eBay, it's actually one of our larger customers, to virtualize the dev environment. So okay, worker has an idea, gets to work, spins up a VM, spins up a virtual network, and moves forward. So I just wanted to give you something like fairly concrete to think about, like how is this stuff being used in practice? So if I take like this heat map of like all of the customers, and I say, so why do people buy this stuff and deploy it? And we had, in the early days of Nasir, we were so naive, and we had all of these ideas why people would buy and adopt technology, and it turns out it's all today, because we're still early in the adoption cycle, it's really one reason, which is just speed. Whatever that is. Speed to innovation, speed to revenue, right? If you're a hosting provider and like a customer comes and they swipe their credit card and they want their VM and you say, okay, come back in 3 months, okay, you probably have problems. If you live or die by innovation, listen, if your developer drives home, has an idea, and can get something in Amazon quicker than if he drives to work and has an idea, you've probably got problems, right? And so, I mean, this is across all verticals. This is big financials, this is large enterprises, this is service providers, that the need to get something done quickly is actually what is getting people to sign checks and deploy things. And we thought originally, it was like low operational overhead, which you can make these great arguments for this. But I think early in adoption cycles, it's not compelling enough. There's also like these great capital expenditure arguments, like, wow, this is non-disruptive. Like, you take your existing data center, you don't touch anything, no lines of configuration, nothing. You deploy software, and like you get all of this awesome stuff, and then you only decide to refresh your hardware when you want better price performance. So you can like, wow, isn't this great from an operational or from a CapEx standpoint? But again, like I think that it's very difficult to make these arguments because both OpEx and CapEx, you're like training people, you're not replacing hardware, the hardware's still there, and so forth. And so today, because we're still part of the early adoption cycle, it really is about the time to get something done. And I think it's very important to call this out, because I think often when you have guys like me that are up here talking to, especially from a vendor, we're like, and it will solve world hunger, and it does everything, and it's a panacea, and we have to be like really honest that like, listen, we're still early in technology adoption. There are critical needs out there, and it's solving them, and there's others that we will learn about later. Okay, so I'm going to go through 3 reasons why this stuff is difficult to deploy, because again, I think this is pretty important. So the first one is, like, I get asked the question all the time, like, you know, we have a system that we built at Nicira that's at VMware now that does exactly this. And I get the question all the time, so what's your biggest competitor? And the reality is that the biggest hurdle to all of this is the status quo. Like, virtualization never allows you to do something wildly new, ever. If you have enough people and money and hardware and time and tolerance for mistakes and whatever else, you can do anything virtualization can. It's actually true for server virtualization, right? Like, operating systems virtualize memory and CPU and yada, yada, yada. So if you have enough time, you can do all of this stuff. And so if I say, you know, here's a normal engagement cycle where I'm kind of working with a customer, like, the number one thing that will slow the adoption of this stuff is like, listen, just don't touch it. I've spent 20 years, it works, you know, and it's fine, and we don't have a lot of these hurdles. And I think that's totally expected in early adoption cycles. Now, right now, I think we're actually in the knee of the curve. There's a lot of demand. I think it's way outpacing the ability of products to deliver, and so I think that we're kind of past this, but it's important to remember that things don't change overnight. So let's just say that, like, I have a customer, and they find this need. They're like, this is awesome technology, and I've got budget, and this is going to solve a pain point for sure. Let's go ahead and do it, which is a lot. Actually, this is a lot. Because there's like some pretty compelling use cases. So even if even if you got huge willingness, and you have budget, and you have blood on the floor that this is going to help solve, it's very difficult to take these technologies and to make an organization consume it. I've seen everything. In 6 years of dev, I've seen everything. I've seen whole teams get fired. I've seen new legal entities be created and teams hired into those just in order to consume this. And the reason is because networking is moving into software, and organizational lines are blurring as a result. And this isn't just about network virtualization. It's more generally about cloud, but I think it's a very acute form of this. So you have all of these very diplomatic, very politic, very excited meetings, and then you sit down and you have in a meeting, and it's war. You got like the security guy, this isn't secure. You've got the networking guy that says, you know, this is crazy. You've got this virtual admin that says, this is all we've ever wanted. And like, I'm certain, like, you know, marriages were disrupted by this type of thing. And I always try and make the point that before consuming this, and this is more general with cloud, make sure before you go down this path that you're ready organizationally to have the communication needed. And in my experience now, going through a number of production deployments, we've got dozens of them, that it's much less disruptive than you'd think it is. But boy, getting to that point of acceptance is not easy. So this is actually my little soapbox, and I just want to say it. So I think that we're still in the architecture war, and everybody's confused, and that makes it very difficult to have the discussion we're having right now. And I think this happens every time new technology gets introduced. Every time technology that gets introduced, that is transformative. So I'll give an example. So in server virtualization days, and I'm not sure if you remember this is maybe 10 years ago, there were different ways of doing server virtualization, or x86 virtualization. So the Zen guys were like, para-virtualization is awesome because you can do batching and it's faster on I/O. And the VMware guys were saying, dynamic translation is awesome because you don't have to modify the guest at all. And there were heated discussions and debates on the differences between these two. And we never talk about this anymore. And the reason is, it actually doesn't matter. Like, customers don't buy architectures as much as they buy products. It's like taking two cars, and instead of racing them, you're like, oh, the engine of this is built certainly. Oh, no, the engine of this is built a certain way. Like, it's very difficult to find truth by arguing about technical details. Like, the loudest guy always wins, or the guy with the most experience, because you always use that as a trump card, or whatever. And we've had 4 years of an industry that had very little products, and so all of the discussion has been kind of, here's my slide deck, and you know, it's got a product behind it that scales infinitely and does everything. And so we're in this kind of this mass delirium that we're finally coming out of now. And so what's exciting, and as you'll see as the industry evolves, is we actually are seeing use cases and customers and ROI very concretely. And I think that's going to actually winnow this dialogue a lot, and I'm very, very excited to participate in that. So I'm going to leave you with one thought, and then I'm done. When server virtualization started, it solved a very simple problem. Like, I wasn't on the sales force or anything, but I would imagine that like an account manager going into a customer would say something like this. If you put in server virtualization, instead of running 5 servers, you run 2 servers. It was really about server consolidation. For disruptive technology, it's very difficult to sell something that isn't really simple because of the educational hurdles of the sales motion. And so if you looked at the early days of server virtualization, it solved one very simple problem. But once it was in place, virtualization is the ultimate level in Venn direction that we're always looking for in computer science. Once it's in place, because it's virtualized, you really control the laws of physics. And then now, tens of billions of dollars in annual customer savings yearly, the operational paradigm of IT has changed. But that wasn't the original. I know the founder of VMware very well. I worked with him at Stanford. Originally it was like, we're going to solve this one problem, but now that you've got the software layer there, and you change the way you do things. And I fundamentally believe network virtualization is on the same type of trajectory, which is now its speed, right? Time to do X, which I've talked about. But once it's in place, you can do things that you really couldn't do previously in networking, right? On visibility, on security, on debugging, on service insertion. And so now, in this talk, I've tried to bring you, I'm like, okay, SDN is a mechanism, is implemented now. Network virtualization, I think, is kind of the killer app that SDN is being used to implement. And I've said, right now, the key use case of network virtualization is improving the time to provision. And the point that I'm going to leave you with is, but going forward, I think it's going to actually change the way we think about and operate networks. And that's it. Hey, thanks very much.
Thank you so much, Martin.